Welcome guys, I'm with Brian Holt from Parkopedia here, and we're just going to have a little chat about what the guys are doing at LCV 2019. So Brian, what is it that Parkopedia are doing, and why do you have an autonomous vehicle?
So the autonomous vehicle is our test bed vehicle with the Autonomous Valet Parking project, and we're here today really to show the progress that we've made in the project. It's a 30-month project funded by the Centre for Connected and Autonomous Vehicles and Innovate UK. Where we come in here with the AVP project is one day when my car is autonomous, or perhaps even sooner than that now, how can I plan a route to a particular spot in the car park and localize myself, i.e. figure out where I am as I'm driving through the car park. So the reason why this matters is because GPS requires line of sight to the satellites. If you don't have line of sight to satellites, GPS is no good to you. So you need an alternative way of localizing within the car park. We could, as an industry, car park operators, could put in lots of infrastructure, thinking Bluetooth beacons or ultra-wideband, radio transmitters. We could do infrastructure in the car park, or you could put fancy infrastructure on the cars, thinking expensive sensors like LiDARs. You could do that, and maybe some kind of technique like NDT matching. Actually, that's what we're using in the demo now, because we're only halfway through the project, just demonstrating waypoint following. But for the purposes of mass deployment, what we want to do is support a really minimal set of sensors. So most cars right now are going to have cameras. They will have an IMU, so that is to say an accelerometer with a gyro and probably magnetometer. They'll have some kind of wheel odometry available and ultrasonics, parking sensors. Most cars are going to have this. The question is, if you take that minimal sensor set and maps, could you work out where you are, and how accurately could you do that? We believe that you can, and that's the purpose of this project, is to prove that.
Okay, and that's exactly what you're testing at the moment, because presumably an ideal scenario would be people buying EVs over the next few years. If they've already got those sensors in, you could actually update them with that data.
So if you've already got the sensors and you've got the maps, our business is to create these maps. So that's what we're going to be doing. We can supply the maps to automotive or tier 1 suppliers. And given the maps and the sensor set, the piece that's missing right now is the software that will make best use of those two.
Okay.
That can be updated. The software can be updated over time. So you're absolutely right. You could have an EV with the sensors. All that's required is the software and the maps.
Perfect.
And the car park itself.
Sounds a dream. And is there anything people can use? What can people do with Parkopedia at the moment? Is there any way they can contribute or get information from you guys?
Yeah, sure. So you could download the app. That's available. You could look at our website, parkopedia.com, if you wanted to find out where you want to park. There's business.parkopedia.com to find out more about what we're doing. And if you'd like to find out more about the AVP project, our website is avp-project.uk.
So I'm with Colin here. He works at Gießen-Knorbe, and we're next to, a waste collection vehicle, and it's electric. Colin, could you just explain what your role is at the company and why you're here at LCV today?
My role at the company is business development, essentially. We're here at the CENEX exhibition to promote our full electric refuse collection vehicle, which we have beside us. We've now built in excess of 10 to 12 of these vehicles throughout Europe, fully operational, and this is the latest vehicle which will be operational in the UK very shortly.
Brilliant, and it's an impressive looking bit of kit. Is this something that the company's been working on for a while now?
Yes, I mean, we've been involved in hybrid technology since 2003 with lead acid battery packs to power the RCV equipment and the bin lifts. Then we moved on to lithium ion power, and in 2017 we introduced the first full electric refuse collection vehicle, which has now been in operation for over 2 years.
Oh, brilliant. Oh, okay. And where's that? Is that in the UK? Or?
No, that vehicle's currently operating in Spain.
Yeah.
We have other vehicles built and operational in Norway, Sweden, in Holland,
Yeah.
Switzerland, and the UK.
Okay. Just tell me about the sort of some of the specs of this vehicle then.
What we need to do is replicate the performance of a refuse vehicle in its traditional state, really,
Yeah.
into an electric vehicle, and we've achieved that. So, yeah, the vehicle will collect a full day's work. It will collect probably a load and a half minimum, which is around maybe 15-16 tons of waste.
Wow. Wow.
And it will collect domestic containers on a domestic collection round of around 12 to 1,400 containers.
Yeah.
On a single charge, and achieve probably 120 miles and back to depot, which is important.
Okay.
Ready for a charge overnight for
Yeah.
the following day's work. And we have a vehicle working in Manchester, which has now been doing that very thing for probably the last 4 or 5 months.
Clearly, there's benefits with having an EV for waste collection in terms of zero emissions. It's quieter. Presumably, it's actually more pleasant for the chaps working in the morning as well. But what are the benefits in terms of running costs for the council or whoever it is operating the vehicle?
Running costs really need to be, the whole thing really needs to be evaluated in the total cost of ownership.
Yeah.
Don't get me wrong, the initial capital cost of the equipment is a tad more expensive than the traditional vehicle. But the benefits are definitely operationally, in terms of charging costs versus fuel costs, maintenance costs, because you've got engines, gearboxes, oils, filters, etc. And the total cost of ownership over a 7-year period could probably work out pretty much the same sort of cost as a total cost of ownership.
Today with the autonomous road sweeper. It's part of an auto sweep project that was funded by the Niche Vehicle Network. The project was a project jointly between Johnson Sweepers and Westfield Sports Cars. So Westfield Sports Cars is a subsidiary of Westfield Technology Group, who also do autonomous vehicles. So this vehicle is a sweeper that's designed to operate in controlled environments. So in the controlled environment, you go along, not just sweep, but identify larger obstacles, objects that need to be picked up manually or by a bigger vehicle. And it will also make sure the road conditions are good, so there's no potholes, the lines are in good condition to allow other vehicles that use those lines for navigation to navigate successfully around the area. So originally, yes, it was a passenger vehicle. So we're currently trialling down at the Olympic Park, and we have previously done trials down in Greenwich in London. The idea came just through a funded project because Julian, our CEO, been speaking with Johnson Sweepers talking about the automation of sweeper technologies. This vehicle's ideal because it actually has the capacity to fit in all the sweeper technology we need, and also has the autonomous functionality. So the sensor payload allows it to navigate autonomously. With a few additions, we're able to also, using camera sensing, identify obstacles and dirt and areas of the road that need sweeping. So on the road, we're quite a long way away because the system functionality in terms of navigation and collision avoidance at the speed you have on roads is not as advanced as it should be. It's about making sure that it's safe before we put it there. So that's why we look at the sort of less more pedestrianised zones, less vehicles, slower moving. It's a much easier environment to work in. We have trials coming up in the next few months, and from then it's development of the software in the system that will allow us to put it in more uncontrolled environments and allow us to build up the functionality of the ACS system.